How's it going, Mathaholics? Let's see if something is proportional versus non-proportional, and if it's linear or non-linear. Okay, so in a linear proportional situation, we have a constant slope, and the straight line needs to pass through the origin. So here we see constant slope, and it passes through the origin. If it's linear non-proportional, we need a constant slope, and then it does not pass through the origin. Now, you see here where it says linear, non-proportional, and constant slope. Well, if this wasn't linear, then it wouldn't need a constant slope. But that's something you'll learn later on. I just wanted to throw that out there just to answer any possible questions that we may have. But you don't need to worry about that for now. So let's see this first problem. Do we have a constant slope? We go up to over 1, up to over 1, up to over 1. So that first part checks out. And then does it pass through the origin? The origin is 0, 0. And as we can see by looking at our little graph here, it does go through 0 and 0. So we're good to go. This one is linear proportional. Perfect. Let's move on to the next one. Let's check, do we have a constant slope? We go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. Yes, this does have a constant slope, but does it pass through the origin? No, it does not. So this is linear non-proportional. Let's look at this third one. This time we're given a table. So let's go ahead and plot our points. We see the first point is at 0 and 1. Next we have one at 1, 3, 2, 4, 3, 5, and 4, 7. So let's draw our straight line. And right away that we see that we can't draw a straight line. Why is that? This is already nonlinear. And then we know it's non-proportional for a couple ways, but the main one is it doesn't even pass through the origin. So this is non-proportional. And how else can we tell? So let's say it was really hard to tell if the line could have been drawn straightly or not. Let's look at our table and let's check our slopes. So let's start over here. To get from 1 to 3, we need to multiply by 3. To get from 2 to 4, we need to multiply by 2. We already see that our slope is not going to be constant. So that is why our points were all over the place. And that's also why we know it's nonlinear, non-proportional. Now let's check this last one. To go from -2 to -4, we just multiply by 2. To go from -1 to -2, we multiply by 2. To go from 0 to 0, we don't need to do anything. To go from 1 to 2, we multiply by 2. And then to go from 2 to 4, we also multiply by 2. So is this constant? Is this a constant slope? Because 0 times 0, we didn't need to multiply by 2. However, 0 times anything is just 0. So the zeros are the only time you can make this exception. And that's pretty much it for this one. We also see that it passes through the points 0, 0. So yes, this is linear proportional. I hope this video was easy for you guys, and I hope the rest of math is easy for you guys too.